In our last video, we were talking about the chain tensioner that's going to go on the gearbox, and we need two of them. So that's one of them that I finished. It'll do, and we got to make another one. And there's the beginning of the other one. And I talked about in the last video how the raw materials and how this gets cut out. So it's a little bit bigger than this one, as I mentioned. Watch the last video for that. But today I'm going to draw out the holes. Okay, I got to mock it up, kind of like I did this one. This one's a little bit bigger for reasons I mentioned in the last video. So I'm going to try to do that today, draw out the holes, and we'll see how far we get on that. Get all the hardware installed on it so it looks like this one. Okay. Also, where are we headed? What's coming up? I have two PMAs. The one that's in the distance there on the gearbox from Windblue, that's model number DC512. And this one in front of me here, this is the one I'm actually going to use in the project. This one is a DC520. Okay. So it's a little bit different. It's got different output. So if you want to know the difference between the 512 model and the 520 model, just go on their website and download the specifications, because the voltage and ampage output, ultimately the wattage output, is different. So check that out. I'm going to use the 520. Going to try that out first. It's a good compromise between voltage and ampage. So we're going to try that first. So that's the one that's eventually going to be mounted into the box. Take out the 512. They're the exact same dimensions and everything's the same, except for the copper winding inside is a little different. Okay, one of the things I talked about in some of the other videos was, at some point, I got to put a sprocket on here. Right now it comes with a pulley, okay, which I don't have that sitting around, I don't think, here. But this one has some basic spacers on it. Okay, you put I think you put this washer on there, and then you put this. They have these spacers, and then there's a lock washer, and there's a nut. Okay, and the pulley goes in there somewhere. Okay, and you lock it down. Well, nothing's really. There's nothing about this setup that absolutely positively locks the pulley to the shaft. Okay, it's just pressure from the nut and the lock washer, on the shaft, right? That's putting pressure, but that doesn't absolutely guarantee no slippage. And pulleys by nature, the belt can slip under certain conditions, under certain loads. And some will say that's a good thing, that's what it's supposed to do, blah, blah, blah. But what we want is, we want a sprocket on that shaft. So we got to drill and tap the shaft. I have the sprockets on order and some other materials that are coming in that I'm still waiting on to kind of take the project forward. So meantime, I got some more work to do as usual. Now, one of the challenges with these PMAs is that this shaft is stainless steel. Now, for your average workshop, your metal shop, no big deal, right? They do that stuff all day long. For me, a little more challenging. So I ordered a carbide bit. Now, some guys are going to tell you don't need a carbide bit. That's overkill. A cobalt bit would do, and maybe even a high-speed steel bit would work if you know what you're doing and so on. But I just went ahead and bit the bullet and paid for a slightly pricey carbide bit, so I hopefully don't run into any issues, and just go ahead and drill this. This is a 7/32 drill bit. This is a 17 millimeter shaft, so we got plenty of space there. All right. Okay, plenty of diameter to work with. And we're going to tap it. After we drill 7/32, we're going to attempt to tap it on our bad boy tap over here. Tap, little hand tapper. If I remember right, I think it's let me see, a quarter by 28 tap, if I remember right. So normally we'd use a number 2 or 3 drill bit to do that for that size tap, but a 7/32 is a good compromise right between the number 2 and number 3 drill bits. So, and it's generally a little bit cheaper. So I went with that drill bit. 7/32 should do the job. Carbide bit, hopefully no problems. Now, there is an additional challenge. Not only are we dealing with a harder steel, stainless steel, but this has a PMA stands for permanent magnet alternator. So there's a strong magnet in here. Okay? And why is that a problem? Look at that. It just attracted to it, right? It's attracted to it. Look, I'm not even barely holding it. Right? If I wasn't holding that up with my thumb, that side should fall to the ground, but it's not. That tells you the magnet's holding it up there, right? This whole thing is magnetized in here. Strong magnet in there. That blue color you're seeing in there is a magnet. Okay? So, why is that an issue? Well, it's a potential issue when we put it on the drill press and start drilling with our carbide bit, because what's going to happen? We're going to get metal shavings coming off out of the hole that we're drilling, and those metal shavings are going to want to do what? They're going to want to go in there and attach to this magnet. So we have to completely close off, either disassemble the PMA, take it all out, which you'd still have to deal with the magnet, because I don't believe the shaft can be separated from the magnet, though I may be wrong, at least not easily. So we're not going to do all that. I don't want to disassemble everything. We're going to completely cover up this entire PMA. We're going to do it with some Ziploc bags and some tape. Okay, there's those Ziploc bags and some regular old tape. A pretty big Ziploc bag that I got here. Okay, pretty good size bag. And we're going to try to put the PMA in there. Use some tape to tape up any remaining holes that are obviously going to be there on the opening of the Ziploc bag. And I even have some what's called press and seal from Glad. Playing Susie Homemaker here. It's pretty cool stuff. You just basically it sticks to itself. So I may need to use a little bit of that too, but hopefully just the Ziploc bag and the tape will do the job. And we're just going to take that PMA, stick it in a Ziploc bag, close it up, tape up whatever's not completely closed up. Just leave the shaft exposed, right, with all the tape and everything around it here. And then the challenge, of course, would be getting the whole PMA firmly locked down on the drill press table, which shouldn't be too difficult. I'll probably just put some thread or rod or a bolt through here and figure out a way to clamp it down on both sides. Get it to sit still, and maybe even through this hole too if necessary. So that's a little bit of work coming up. But today we're going to try to finish up the other chain tensioner, and then on to a serious challenge, drilling a stainless steel shaft and keeping it from getting contaminated. So that's next. That's what's coming up. So I just thought I'd share that with everybody. Okay, talk to you later.